Are you- all right. My name is Mark Corrado. I'm living in Denver. I'm from Omaha originally. I was one of the original co-founders of the GDG meetup, GDG Omaha specifically. But yeah, I'm a freelance, so talk to me. But anyway, so so I noticed from the just the people that were in that are in our chat in the room, we don't have a whole lot of like Android experts here, so I made sure to write some explainer of.
Yeah, Mark, I can't hear you. I don't know about other remote people, but I'm just gonna say I can't hear you.
I just started muting him and
Oh, you didn't know. I need to talk over here.
Actually here you can just talk to my here. You're good.
Sorry.
No, you're good.
Should I start over?
No. I literally just paused you. Sorry.
Oh, okay. Yes. So from the people in the room, we're going to try to go from the beginning stages of Jetpack Compose, like a quick overview, and then we're going to get in some details because I've been working in Jetpack Compose for about the past year and a half. And when I first started doing it, these tools weren't there. So it's pretty cool that the tools are there now. So I want to show you them. I learned about it in DroidCon. I'm completely ripping off some people there at DroidCon. I got all the information from them, some references at the end of my video, or at the end of my talk. I'll post the slides so you can go get more detail from them. But this is just to show you these tools exist. They didn't exist before, and Jetpack Compose is getting a lot cooler than it was previously. All right, so first is first. Android UI development has been imperative historically, which means like if you've done Android development in the past, you've seen the tried and true syntax that we've seen for a long time: find view by ID and set text, set the color on stuff. That's what we've been used to for a really long time, right? So just keep that in your mind, that we used to be more in the imperative world, right? But as apps have been getting more complex, the industry has changed. They've been introducing things that are more declarative by things like flows, live data, RxJava. And by declarative, I basically mean it's like you might have an object, a view model, a list, a service, something that you're observing and you're waiting for it to change so that you can update your UI, right? So it's a little bit of a different paradigm than previously. And yeah, that's just kind of what Jetpack Compose is. And we'll kind of get into more detail. So, like I said, we're moving towards more of a declarative framework, but like, that wasn't, that wasn't exactly how we write our UI. We're still kind of, a lot of the UI we're still writing was still doing the whole tried and true view by ID setting things, right? But now Jetpack Compose is changing that. So we display the UI using composable functions. I'm going to go through this kind of quickly and we'll get in more detail, and please ask me questions if you have them. So we display the UI using composable functions. Composable functions take in data to describe the UI. Composable functions emit UI by calling other composables. They don't return anything, and they're free of side effects. They shouldn't modify global variables. So there's a lot of rules that like kind of come into play with Jetpack Compose, and they can be hard to remember, or just like things, guidelines, things to go by, so that so that the recomposition of these composable functions works as you expect them to. So there's basically these are the rules. Like some of these things you cannot return anything from composable functions. The compiler will not let you do it. But some of these other things, you can break these rules and then your UI will just be janky and broken. So it's kind of hard to remember these things. And like, we might start working on a big team where there's overseas developers who are working on something. Maybe they don't know all the best practices, and then your app is janky and you're not really sure why. So let's go to this. Okay, so I'm going to get out of this and we're going to look at some code. We're going to go over to, I'm at 0. Okay, great. So we're Android Studio. So all I've done so far, can you guys see this okay? Yeah, it's okay. Yeah. So basically all I've done so far in this project is say file, new project, and then empty compose activity. I haven't done anything so far. I just want to show you like what this project is, okay? So all I've done is created a new project at empty compose activity, and this is what's going to pop out. So I just named it Jetpack Compose Demo, It's going to provide you a surface. It's just like a container of objects. It's one of the things that's included in the Jetpack library. And all they're doing is providing a composable object, a custom composable object, right, that we've defined ourselves, which is located right about here. Cool. So it's getting passed in a string, and that string right now is Android, gets passed in, says hello name, and then this is my emulator over here on the right, and that displays hello Android. That's our first hello world application. Great, awesome. And then if you go down here, what this basically is telling you is that there's this preview mode. You go over here, if it'll load my computer. This is an old MacBook Pro, so it's gonna struggle. Maybe it's not gonna do it. Okay, never mind. Oh, there it is. Okay, great. So if you were trying to iterate quickly on some of these Jetpack Compose views, the way that you do that is you add a annotation that says preview, and then you basically pass in your same old theme and your whatever objects you want to see. And you can get a quick little view of that in your IDE. Pretty cool. So, but this thing isn't really necessary. So yeah, just so you guys know what this project looks like. If you see the set content object function call here, you will if you've done Android development in the past, what we would have done is passed in an ID to an XML file, and that would have an ID on it, and then we'd say find by ID to this button, and then we'd set it or click it or listen to a click event, that kind of thing. But instead of doing that, we're in Jetpack Compose land. Okay, great. So what is our talk about though? Our talk is about the compiler and what this thing is doing underneath the hood. So we're gonna check out see how this works. Okay, great. So go back to my slides. Bing, bang, boom. Okay. I'm not going to go into detail about the implementation of how to set up these compose metrics, but there's a link at the end. They explain it way better than I do. Basically, these are the steps to get this these metric printout that I'm going to show you in a second here. What we're doing is this is basically your root build.gradle file. If you're unfamiliar with Android development, it's basically where you set up your project config, things like that, your build config, things like that. So we're passing in some things. Basically, the important part is that we're saying, hey, oop, gosh, I clicked, my bad. Can I go back that way? Shoot. Sorry, I went the wrong direction. Did I lose my, oh, I went back. Is that what happened? Shoot, sorry. 1 second, technical difficulties. I knew I was going to do it. Let's go back to my slides. I used the shortcuts on my laptop and went out of my talk. Sorry, my bad. Cool. Okay, so we are saying that the compose compiler reports, we're enabling them, and then in the next, what we did was we set a flag onto our Gradle file saying that we enabled to listen to a flag that is saying, hey, we want to be able to set this enable compose compiler reports, and then in your terminal, when you have to actually run a separate command on a release or on a release build of your app, so that you can see these reports. Sorry, it's a little complicated, but all I really do is run this command. Yeah, you can see it right down there. The same command that I put right here. And they explain why they went through a release file, just so that there's no minification there, and yeah, basically that's all it really is. So if we go to so after you run that command, what gets compiled and built is this compose metrics folder, and I'll show you kind of what that looks like. So what I did was I went ahead and on this branch this simple branch that we were on before, right? Oh shoot. Yeah, so in the second branch, sorry, I remember where I was. Great. So in the second tag here is where I've actually added some complexity to our compose itself. So all I've really done is, I'm gonna go ahead and run this so you can see how it changes my emulator on the right side. So what I have here is that same surface that we had before inside that same theme that we had before. All I did was add a column so that we can structure them in a list. And then I have a list of names, and I'm passing into that same greeting we had before. And just to see what this file kind of outputs, we're going to look at this compose metrics. So just to save some compile time, I threw all these folders into another folder so you can just take a look. But this is the a snapshot of what this would output at this moment. And if we go back to the emulator, it should just say, yeah, hello Zuko, hello Rudy, the name of my dogs. It goes over the list twice, bing, bang, boom. Okay. And then we look at the file itself. So it'll output 4 files. This is basically saying, my fan is going crazy right now. There it is. There we go. So in the module.json file, basically it'll give you an idea of all the composables within your project. And it'll give you a lot more information that you probably understand it at right now. But the first things we're going to think about and consider are the skippable and restartable composables. And so this is just this is you know, overall explanation of your entire project. And if we go to the composables.txt itself, it'll give you this is the coolest part. This is the whole point of this talk, is the fact that it'll give you a printout of all of your composables within your app, essentially. And this is not the right file. I'm in the wrong place. No, that's right. Yeah. So if we look at, so this is where it'll pop out into your project folder here. Sorry, I think this is not structured the way I want it to be. This is 2. Sorry, I think my tags are screwed up. I knew I was going to get this wrong. Oh, okay. So basically, if we go to 3. Yeah, this is right. Okay, great. So I replaced that previous composable with by instead of just using that greeting and iterating through that list, I'm actually replacing that composable with this thing called a dogs card, right? And we'll look down at what this composable looks like. And all we're doing is iterating through a list. And that's the same list of strings that we had before. And we're providing that list to this composable. And if we look at what the this composables txt file will look like, it'll say that this is unstable. And so if you see how the name right here is dog list, it'll correspond, to this list right here. And it says that the list itself is unstable. And basically why that is because the list itself, it can be mutable or immutable. And the whole idea of Jetpack Compose and recomposition is that the compiler itself needs to know if your individual composables are immutable, stable, skippable, or restartable, so that if the items that you pass into it, if they're stable, then it'll know, hey, this item hasn't changed since last time, I can skip over it, or it'll just know that whenever I need to get more information on this thing, I have to restart the whole entire object, which is how you can identify like essentially janky like UI behavior if you have a whole bunch of complex composables. So if I go to my this last checkout here and see what this folder looks like, compose 4, composables here. So what I've done here, so this is, so I want, so since this is, I want this list to not be, I want this to be restartable, and I want this to be immutable, so that I can essentially be able, so this composable knows that whenever you pass new data to it, if you pass new data, then it has to be completely redrawn. But if you don't pass new data to it, then you can just restart it or recreate it. So the way you would have to do that is by passing this immutable. You basically have to wrap it, and it's that same dog list that I provided before, and you have to pass it into this dog metadata, and then within your dog card up here, you pass in you wrap your list into this dog metadata so that it knows that this list won't change. And if we look back at how the composable, the actual printout from the compose compiler looks, you can see that now this is restartable and skippable because the dog metadata is stable, and before it was unstable. So now it knows that, hey, if this data has not changed, then you can skip this whole dogs card object entirely. Yeah, let's see here. I think that's pretty much what I wanted to cover. Like, so we can go into more detail about like, state hoisting and things like that. So if you want to try to, let me show the code again. If there are times when you want to pass say a lambda, or maybe your view model, or more complicated objects to your cards in general. Maybe it needs to listen to some data changing off of your view model instead of just static data. Then you would use your things like flows, and you would get a mutable state off of your flows. And if you want to trigger off of data, you have to pass lambdas, which is something that somebody brought up previously, but I didn't have slides to discuss that. But yeah, that's kind of the premise of my talk here. That's about it. I just wanted to show, because this tool didn't exist when we first started doing Jetpack Compose, and it really just helps you identify like the things that are going wrong within your app, because the goal is that you want your composables to all look restartable and skippable, so that, and have this stable keyword if the object actually is not going to change and is actually stable. Because sometimes, of course, you have mutable states that things are just not going to be skippable. So but yeah, that's basically what I have here. Is there any questions so far?
Yeah, I have a question. So like in theory, if you were to adopt another dog, or in the the ill-forgotten sense, you lose the dog, like it would have to be unstable if you wanted to mutate the list, right?
Yeah, exactly. And so like typically it's not the best idea to make, unless this list isn't going to change, having a immutable list is probably not the best idea. Most of the time they are going to be immutable lists. But yeah, it's just kind of, this is just kind of an example of if you see something that you think, if you know that it's not going to change, that's basically when you use that immutable state. And it also comes into play when, say, the Jetpack compiler only will understands the objects that it compiles itself, right? So if you say pass in another object from a library and it says, hey, that's unstable, you have to wrap that object and say that's stable or not.
Okay, and then the follow-up is stable versus unstable on like a view cycle. Unstable will always redraw versus stable is able to skip. That's where it's like, is unstable inherently unskippable? Or yeah. Oh, okay.
Yeah. So restart, like most of your composables are going to be restartable, just because like, if it doesn't know what to do, it's just going to restart. Like that's kind of default behavior. But if you do the work and make sure and tell the composable that it's not going to change, then you're kind of utilizing the power more of the recomposition itself, so that it knows, okay, I don't have to rebuild this piece, but I need to rebuild this piece. And so it just makes your UI refreshing a lot cleaner and things like that.
No, super cool. Thank you.
Yeah.
So if you, from my experience, if you want something to like not recompose, which we definitely have not done any optimization for this in our app, but you like use remember, does remember basically make it stable? Like, or is that two completely different concepts?
Yeah, I try not to go down that path too much to explain the mutable states and remembering within the composable. But basically the idea around that is that if you have state, it needs to be hoisted to the most common place where it's shared. And if you want to change state in a lower composable, you would pass a lambda to it, and then in that shared state you would update, say, the view model or something like that. and then, you know, you're just passing a lambda to that lower composable, and then it'll trigger, and then it'll know to update the view model in that higher scope. So that your shared state is like at the most common denominator between the composables.
Okay.
What do you think, everybody? Any more questions? Sorry, I wasn't looking online. Is there any questions there?
And I think like Standard Studio IDE now gives you tools to determine whether you're over doing over recomposition of your screen right now. So like basically this would be like an extreme optimization. This is the tools you have to use to make it get to the most optimal avoiding of the re-rendering. That's like basically this is how you solve the problem of the recompositions in your views.
Yeah, exactly. Like you know, like I said, when we first started doing Jetpack Compose, these outputs didn't exist at all. So like just being able to debug this and be able to see like, oh, what is going wrong? Why is this recompiling? Because traditionally what we've been doing is just adding print statements and things like that. And but yeah, this makes it so you know, especially when you have nested composables within another composable, things get really wonky really quickly. So yeah, this really helps clean it up. And you know, because there's been times where you'll just see your log cat just, you know, recompositions like in the 40s before you even see the thing for the first time. You're like, yeah, something's obviously going wrong here. But we didn't have the debugging tools, you know, before this. Cool. Well, thanks for your time, everybody. Appreciate it.
Thank you.